Hello everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller and its embedded systems design, what we have covered some topics of the unit number first. Now, in this lecture, we are going to start some advanced microcontroller techniques, that is AVR microcontroller. So, today we will discuss its part 1, that is some techniques of architecture of AVR, its functions of AVR, etc. These are the table of contents we will cover in our today lecture, that introduction of the microcontrollers, AVR family, what the AVR family is, what AVR stands, importance of AVR, why we are using AVR microcontrollers, AVR family architecture, that is what are the various microcontrollers available in the AVR family, what are the various AVR features we will cover in today's lecture, AVR pin diagram we will cover, and pin description of the pin diagram. After that we will see what are the available AVR registers in our microcontroller. After that, in our last slide we will see what are the various applications of AVR microcontroller. So, let us start with the basic introduction of a AVR. So, the basic architecture of AVR was designed by two students of Norwegian University, that is Alf Egilbogen and Vegard Vollen. So, basically AVR, what is the meaning of AVR? Means it is developed by the Alf Egilbogen and V means it is developed by the Vegard Vollen. So, AV implies the name of the two students who developed this architecture, and R stands for RISC architecture. One of the most important feature of AVR microcontroller is that it has a RISC architecture. So, RISC processor, basically what is RISC? RISC means reduced instruction, R means reduced, I means instruction, set, S means set, and C means computer. So, it has a RISC architecture, means it has a reduced instruction set computer. There is other processor available as well, like CISC, complex instruction set computer. So, AVR follows RISC processor. So, you all so now it is clear to all of you that AVR, what AVR stands. AV means the name of the two students, Alf Egilbogen and Vegard Vollen, and R means the RISC architecture. Okay. So, it was bought and developed by Atmel. Atmel company came with microcontroller, AVR microcontroller in 1996. It is developed in 1996, and after that American company Microchip, it acquired this microcontroller in 2016. After that AVR, the manufacturing of AVR is since 2016, Microchip developed this AVR. So, AVR derives its name, we have already discussed that AV stands for Alf Egilbogen and Vegard Vollen. So, it is a RISC microcontroller, also known as advanced virtual RISC. So, basically it is a 8-bit RISC architecture. So, in our previous lecture we have seen that there are other microcontrollers available like 8051, which was 8-bit microcontroller. After that we have seen about the other microcontrollers. So, one microcontroller may be a 8-bit, someone may be a 16-bit. So, AVR is basically a 8-bit RISC architecture. RISC means reduced instruction set computing microcontroller. So, these are modified Harvard architecture. Actually, there are two types of architecture in our processor. One is the von Neumann, and other is the Harvard architecture. So, AVR microcontroller follows Harvard architecture. Harvard architecture means that, just a minute, I am erasing the things. So, a Harvard architecture means that there are two types of memory, program memory and data memory. Both are allocated to a different memory locations. So, there are different memory locations for both the program and the data memory. So, the execution can be faster. So, there are this is a modified Harvard architecture. After that, this is first in-house CPU. In-house means all the components are integrated on the same chip. So, in-house means that it has a all the components are built on a same platform. So, this is designed by Atmel and it can execute 1 million instructions per second. MIPS means that it can execute 1 millions of instructions per second. with a clock frequency. Clock frequency needed to run and trigger the processor is 1 megahertz. So these are the some introduction of AVR microcontroller. After that we will see some more of the features of the AVR microcontroller. This is basically a complete on-chip flash memory. Here there are two words, complete. Complete means all the components, whether it is timer, controller, all the things are integrated on a same chip. That's why it is called a complete on-chip flash memory. On-chip means all the components are placed on a same chip, that integrate on same chip, and flash memory means AVR has a flash memory. There are other memories available. We have seen that RAM, ROM, etc. And one of the important features of AVR is that it has a flash memory. So for program storage as opposed to one of time programmable ROM, EPROM, it is used by other microcontrollers at that time. So we have seen that in our previous lectures there are other memory available, ROM, EPROM. So what is doing here is that ROM, what is the meaning of ROM? ROM means read only memory. It has only we can read it. Okay. So there is another memory available, EPROM. So you can see that in ROM we cannot rewrite anything. It is only a read-only memory. But in current scenario you can see that USB devices are available. But you can see that in USB device you can erase memory, you can rewrite the contents again. So how this is possible? This is possible because of the EPROM, that is electrically erasable programmable read-only memory. So after that, onboard peripherals, same thing here. On chip means all the devices are available on a same board, that is onboard peripherals. Whether peripherals you can see that ADC, DAC, DAC controllers, power supply unit, all the things are available on a same board. After that we have most AVR have some additional features. They have a ADC, programmable pulse width modulation, and different kinds of series interface, just such as USART, SPI, I2C, CAN bus, controller area network, USB, all are integrated on the same platform. ATmega and XMega AVR. In the next slide we will see what are the different types of AVR available. So XMega is one of them. XMega AVR chips became extremely popular after they were designed into the 8-bit Arduino platform. So AVR microcontrollers find many applications as embedded system. In last slide we will see what are the various applications of the AVR microcontrollers. So they are especially common in hobbyist and educational embedded applications. So this is the introduction, basic introduction of the AVR microcontroller. So AVR microcontrollers are available in three categories. First one is the teeny AVR, second one is the mega AVR, and third one is the XMega AVR. Teeny means, as the name implies, teeny which has small things, which are small in some quantity, in size, etc. So teeny means it has a less memory, it has a small in size, it is suitable only for simpler applications, which required less processing, less processing speed, less frequency. So teeny AVR is devoted to that. Mega means something greater than its basic unit. So mega means which is something bigger. So basically these are the most popular ones having good amount of memory. Memory is expandable. Teeny AVR has a less memory, but it has memory up to 256 kilobytes. So higher number of input peripherals and suitable for moderate to complex applications. After that there are third category, that is the XMega AVR. XMega means it is used commercially for complex applications which require large program memory and high speed. So XMega AVR is have more memory, more pins, more a larger size as compared to other two categories. So this table represents the comparison between the different series of AVR. First one is the teeny AVR, second one is the mega AVR, and third one is the XMega AVR. The number of pins available in teeny is 632. Here mega is 28 to 100 pins are available, input output pins are available, and X mega have 44 to 100 pins are available. Flash memory is 0.5 to 8 KB in case of teeny AVR, and in case of mega AVR the flash memory is 4 to 256 kilobyte. As we have seen that its memory is available, amount of memory available is up to 256 kilobyte. It has extended peripherals. Basically teeny means it is small in size, and mega means it is extended peripherals. Peripherals can be extended to some large extent as compared to teeny AVR. After that, X mega AVR. X mega means that it has more flash memory, that is varies from 16 to 384 kilobytes. It has a DMA. DMA means that direct memory access, event system included. So what is DMA? In the previous lecture we have seen that the concept of the DMA. DMA basically direct memory access. We have seen that there are in basic architecture there is a CPU, there is a input output peripherals, and third one is the memory. So in general system, input output peripherals access memory through the control of the CPU. CPU permits input output devices to access memory. But in case of a DMA system, there is no need of the CPU. DMAC controller will work as a CPU and provide the direct memory access of the input output devices. Okay, so this is a DMA. Event system. Event system means what are the types of memory, how much memory set for the particular system. So this is the event system included. So this is the AVR microcontroller categories. Okay. Now the question arises, what is the importance of AVR? Why we are studying AVR microcontrollers? First is, it is fast as compared to other microcontrollers available. If you are looking into other microcontrollers like 8051 microcontroller, PIC microcontroller, the speed of the execution speed of the AVR is more. That is, AVR microcontroller executes most of the instructions in single execution cycle. In a single clock, it can execute maximum number of instructions. So AVR are about 4 times faster. It is 4 times faster as compared to other microcontroller like PIC. So they consume less power and can be operated in different power saving modes. One of the important feature of AVR is that it has a different power saving modes. Okay, we will see in our further slides. So table below shows comparison between the 3 most commonly used microcontroller family: 8051, PIC microcontrollers, AVR. So the speed of the 8051 microcontroller is slow as compared to AVR microcontroller. It has a fast execution, memory is small, but if we are looking into AVR, there is a memory available to the processor is more. Architecture, 8051 follows RISC architecture, and both the PIC and the AVR follows RISC type of processor. We have seen our previous slides. ADC, it is not present in 8051 microcontroller, but in case of a PIC microcontroller and AVR, it is inbuilt into the chip. Timers inbuilt on the microcontrollers, timers are inbuilt. PWM channels not present in the 8051 microcontroller, but in case of PIC and AVR, it is present inbuilt into the same chip. So there are various types of features available, advanced features available in AVR microcontroller as compared to the 8051 microcontroller. So we are using this microcontroller in our most of the applications. Okay. So this is AVR family architecture. If you look into the diagram, there are a lot of blocks available. First, we will start with the ALU. What is the meaning of ALU? ALU means that arithmetic logic unit. So let us write here. A means arithmetic, L means logical, and U means unit. What is arithmetic and logical unit? Basically, these units perform the arithmetic operations. Arithmetic operations like addition, subtraction, multiplication, division, etc. And logical operations like which is related to the logical operations like logical AND, logical XOR, etc. So basically, this unit perform ALU operations. The data provided to the ALU unit is by the general purpose registers. It has a 32 into 8 general purpose registers. In our previous in 8051 microcontroller, we have seen that there are 8 general purpose registers available in 8051 microcontroller, that is from R0 to R7. But in case of AVR microcontroller, there is 32 general purpose registers available, that is from R0 to R31. Total counting is 32. Okay. So the data provided to the ALU is through the 832 into 8 general purpose registers. So how the instructions came into the general purpose registers? Instructions are provided by the instruction register. Here you can see that the instructions from the instruction registers are provided into the 32 into 8 general purpose registers. So there are some other blocks like program counter and a flash program memory. What is the role of the program counter? Program counter basically point out to the address of the next instruction to be executed by the microcontroller. So basically, whatever the next instruction to be executed by the processor, it has some address. So the address will be the address will be pointed out by the program counter. Okay. So there is a flash program memory. Let us take example. Let us take example. Let us take that. Just a second. I am erasing the things here. So let us take MOV instruction. Let us take one instruction MOV A comma R1. Let us take this one. Okay. So whenever we are executing this memory, its memory location like 0000, let us take 4000 here. This memory location implies to the program counter, and whatever we are doing, this is saved into the flash program memory. Okay. So whatever execution take place through this instruction, we have take some sample. There are a lot of instructions available. Whatever we are executing, the execution of the is stored into the instruction registers. These instructions are come from the flash program memory to the instruction register, and after that it is going into the general purpose registers. And what will be the role of the instruction decoder? Instruction decoder decodes whatever we are doing here, it decodes that and provide into the control lines. So instruction decoder are decoding the instructions for our system through the control lines, Okay. So after the execution of the instructions, the data will go into the 32 into 8 general purpose register. Let us take here x1 and x2. When we are performing the instruction, some arithmetical logical operation in x1, x2, the data, the result will be will further provided into this line, and from this lines the result will flow into the 8-bit data bus. So there are other units available like data SRAM, EEPROM, input output lines. So data SRAM means static random access memory. So these are controlled through two lines, direct addressing and indirect addressing. So they are connected to into the 32 into 8 general purpose registers. And whenever we are executing these things, there are other blocks available, EEPROM, electrically erasable ROM, in addition to the flash memory, input output lines available. So all are connected through the 8-bit data bus. Basically, we have seen that AVR microcontroller is 8-bit microcontroller. So it has a data bus of 8-bit. Okay. So there are other units available with the 8-bit data bus like interrupt unit, SPI unit, watchdog timer, analog comparator, input output module 2 and N. There are some input output modules available from 1 to it may vary in the large numbers as well. So there is an interrupt unit. What is interrupt? Basically interrupt unit handling the interrupts. Basically whenever we are doing something, if there is a sudden signal came. So what this type of signal is an interrupt signal. For example, if you are watching a movie and your parents ask that you have to do your homework and do something. So what will you? What will you do? You either you stop your whatever you are doing current now, and you are you are following the things which are have been asked by your parents. So you will do the work according to some priorities. For example, if you have 4 lectures at particular time, so you will access one lecture at a time. So all these things are based on priorities. So interrupt unit will do the task according to the priorities. So this will handle the interrupts. After that, there is a SPI unit. We have seen in our previous lecture that SPI stands for serial peripheral interface. So there is unit which are controlling the things of SPI unit. There is a watchdog timer. Watchdog timers, in our previous lecture we have seen that watchdog timer basically this type of timer will reset or restart the system in case of software fault. If there is any software fault, if there is any type of error facing by the AVR microcontroller, this type of watchdog timer will monitor and take that system into the some safer mode. Okay. So this is the working of watchdog timer. There are analog comparator as well. So input output modules. So these are the description of the blocks available in the AVR family architecture. Okay. So after that, we will see the features of ATmega AVR microcontroller. What is ATmega? ATmega means Atmel, Mega means its series. Mega, we have seen in our previous slide that there are 3 categories available of AVR microcontroller: Teeny, Mega, and after that X Mega, etc. So it is one of the families. So 80 means ATmega, Atmel, and Mega means its series, and 32 it's basically 32 input output pins are available. ठीक है, ओके, इन 32 registers are available. So we will see the features of ATmega 32 AVR microcontroller. This is one of the famous microcontrollers in a series of AVR family. Okay. So basically this is 32 kilobytes of in-system programmable flash memory. We have seen that what is flash memory. So it has 32 kilobytes of in-system programmable flash memory. Okay. So it has both the capabilities read while write capabilities. Okay. It has a 1024 bytes of EEPROM, electrically erasable programmable read only memory. It is of 1024 bytes. It has 2 kilobyte of SRAM. It is available in 40 pin DIP package. DIP means dual inline package. Dual inline package means that if we can see that it has a 40 pin architecture. So 20 pins are in the left side and 20 pins are on the right side. So there is similarity in between them. Dual inline package. There are other packages also available like quad flat package, etc. So this follows 40 pin DIP package, and it has 32 general purpose input output lines. We have seen that. It has a JTAG interface. JTAG basically joint test action group. If we are going to test a circuit, if we are going to verify the circuit, we have to use JTAG group, joint tag action group. So this is for the scanning, for testing of the circuit. For boundary scan means for testing the circuit, for verifying the circuit. It has a on-chip debugging support and program. Debugging means if there is any bugs, error in our system, it can be fixed by debugging support. It has a 3 flexible timer counter with compare modes. It has a flexible system, so it has a 3 flexible timer and counters. Okay. After that, it has an internal and external interrupts. We have seen that there are many types of interrupts available in our system. So it has an internal and external interrupt. It has a serial programmable USART, universal synchronous asynchronous receiver transmitter. It has a byte oriented 2-wire serial interface, I2C, inter-integrated communication protocol. In our previous lectures, we have seen the detailed explanation of I2C. It has a 8-channel 10-bit analog to digital converter. It has a programmable watchdog timer. In our in previous slide, in description of the block diagram, we have seen the watchdog timer. SPI serial communication protocol, 6 software selectable power saving modes. So these are the basic features of ATmega 32. Okay. So now the question arises, what should be the pin diagram of 8051 microcontroller? We have seen that it follows 40 pin DIP package. DIP package, dual inline package. So there are 20 pins available here, 1 to 20. Opposite to the 20, there is a 21, and 21 to 40 here available. So basically, it has 4 ports: port A, port B, port C, and port D. Each port, each port have 8 pins, and each pin is dedicated to some functions. For example, if we are looking into this pin, it is dedicated to PA2/ADC2. So let us explain all the things. Port A, it has 8 pins, that is vary from PA0 to PA7. So the counting is 8. So basically port A serves as analog inputs for A to D converter, and it is also act as an 8-bit bidirectional input output port. It has a bidirectional work. That is, it can provide it can be configured as an input as well as output. Okay. So it has a to D converter is not used internally. So here this is the port A. This is the port A. After that, there is a port B. Port B varies from PB0 to PB7. So counting is 8. So also this is a bidirectional input output ports. At one time it can be worked as either a input or output. So it can work as an input and output. When as inputs, these are pulled low if the pull up registers are used, and it is also provides various special function features of the ATmega 32, and it has a it works as the output unit, and it have a symmetrical characteristics with high source and sink. High source and sink matlab it can handle large number of its low carrying capacity is more. And port C vary from PC7 to PC0. Here there is a port C. It varies from PC0 to PC7. It has some another functions as well. So port C is an 8-bit bidirectional input output ports. So if JTAG interface is enabled, if JTAG is enabled, the pull up registers on pin PC2, TCK, PC3, TMS, basically there are some other functions as well in addition to the input output, and PC5 TDI will be activated. Okay. So after that, port D is also available. Port D basically varies from PD0 to PD7. So it is also a bidirectional input output port with internal pull up resistors. Okay. VCC basically ground, digital voltage supply, and ground, that is VSS. VSS is ground. Reset, basically reset, when we are resetting the microcontroller, it will go into its initial value. So here in AVR microcontroller there is reset pin available to set the microcontroller at mega 32 its primary value. XTL basically these are used to generate the clock pulses, that is a particular frequency operation for the AVR microcontroller. So it is an input for the inverting oscillator amplifier and output from an inverting oscillator amplifier. AVCC basically it is a supply voltage pin for A to D converter and port A. It must be connected with VCC. So A means analog, VCC power supply. It has an analog power supply as well. It has a reference. A reference is basically analog reference voltage for the digital to analog converter. So these are the pins available in our AVR microcontrollers. So after that there is a registers available in AVR. It has 32 general purpose register varying from 0 to 31. So we have seen that in 8051 the general purpose register available is from R0 to R7. Here it is 0 to 31, total 32. So here if we are looking into this, each register is of 8 bit. 0 to 7 means it has 8 bit from R0 to R31. So R26, from R26 to R31 it has some another features. It has it is divided into 3 categories: X category, Y category, Z category. So each is further divided into a low and high. So if we are looking into Y register low byte, Y register high byte. So what are basically all these things? These are the register organization. The register file begins at the data memory and contains 32 general purpose registers that are directly connected to the ALU. Basically we have seen in our block diagram that ALU getting the data from the general purpose registers. So basically they are used as operands. There are two kind of things in instruction: opcodes, operand. Opcodes means operational codes in which these are the machine codes, and operands means what we are doing into the operands. Okay. So the general purpose working registers are externally important and useful for any data type of manipulations in AVR. After that we have seen that R26 to R31 this has some different functions. So basically this is working as a pointer. Pointer means that they have an index memory location. It has some memory location which is pointed out by the X, Y, Z registers. Okay. So this is register file. So we can see that X register, Y register and Z register divided into two parts: low, high. So each we can see that the range is from 0 to 7 is dedicated for the low, and 0 to further 7 is dedicated to the YH. So basically in 8085 microprocessor we have seen that the pairing of BC, D, HL. So in same way it is divided into this. So basically 8 low plus 8 high, this is equals to 16 bit. So this is the 16-bit address pointer. They are working as a pointer. They are basically it has some address which is pointed out by the registers. So in last slide we have seen that there are the applications of AVR microcontroller. There are a lot of applications available in signal senses. We are using AVR microcontroller for data acquisition. Basically to acquiring the data we are using microcontrollers, AVR microcontroller. Motion control for displays data on LCD. To interface motors, GSM, GPS applications we are using AVR microcontrollers. For automize heavy machinery we can use AVR microcontrollers. For development of unmanned aerial vehicles, one of the major applications of the robotics, and these are used in using in irrigation control, we are using AVR microcontrollers. It is used in industries for the different type of machines. So there are lot of applications available of AVR microcontrollers. So thank you. I hope you have enjoyed my lecture. Thank you everyone.